Okay, we're going to look at some of these trigonometric equations where we sort of have these trigonometric functions as smaller parts of a larger equation. And what our goal is in all of these cases is to reduce it down to something simple like this. So one trigonometric function equals some value. And when we have this sort of situation, we can solve it very easily via normal methods. Now, in this case, what we're going to have to do is call upon an identity to sort of make it function here. So what we're going to recall is that sine squared theta plus cosine squared theta equals 1. And we're going to use this, they call that the Pythagorean identity, to rewrite this equation in terms of only one trigonometric function here. So what I'm going to do is I'm actually going to rewrite cosine here. So I'm going to rearrange this little equation for cosine. I'm going to say cosine squared theta equals 1 minus sine squared theta. And I'm going to totally transform my function here. So I've got 3 sine squared theta minus 2 lots of 1 minus sine squared theta minus 1 equals 0. And now I'm just going to do some mathematics to make this simple. So we've got 3 sine squared theta minus 2 plus 2 sine squared theta. That minus times a minus there. Minus 1 equals 0. So I have 5 sine squared theta minus 3 equals 0. So I have 5 sine squared theta equals 3. Sine squared theta equals 3 over 5. What this means is sine theta equals either positive square root 3 over 5 or negative square root 3 over 5 equals sine theta. Now, you would actually have to go ahead and solve both of these equations. So you'd get a set of solutions for this first equation here, and then you have to turn around and find this set of solutions for this second equation here. I'm just going to, I will leave you to do that yourselves with whatever method you prefer. So once you're here, you've got this equation 1 and you've got this equation 2, and you'd solve it via normal methods. We'll have a look at this one. So here we have a similar sort of situation. 6 cos squared theta equals 1 plus 5 sine squared theta. Exactly the same. So we're just going for the cos squared theta plus sine squared theta equals 1. And again, we'd have to introduce that into this, this equation to reduce it down to a more simple trigonometric equation. So this would become, if I jump in here, 6 cos squared theta. We're going to change sine here to be 1 minus cosine squared theta. So I'm going to rewrite sine squared theta as 1 minus cosine squared theta. So 6 cos squared theta equals 1 plus 5 multiplies 1 minus cosine squared theta. So that's 6 cos squared theta equals 1 plus 5 minus 5 cosine squared theta. So then I have, I'm going to add 5 cosine squared theta to both sides. So I have 11 cosine squared theta equals 6. So I have cosine squared theta. Oh, there's a sine theta at the bottom here. I should say cosine theta. So cosine squared theta equals 6 divided by 11. So I have my cos theta. Cos theta either equals positive square root 6 over 11 or cos theta equals negative square root 6 over 11. And you'd solve both of these via normal methods. So you'd have a load of solutions there in this given range. Last but not least, we have this one. Have a think, which sort of equation do you reckon we're going to have to use for this? So I think actually the best way forward is to go tan theta, well, the only way forward, equals sine theta over cosine theta. And let's rewrite that here. So I have 2 cosine theta equals sine theta over cos theta. And we can now put this all on one side. So I'm going to multiply both sides by cosine squared theta. That becomes 2 cos squared theta equals sine theta. And now let's bring that sine theta over. So we have 2 cosine squared theta minus sine theta equals 0. Now notice we've got 2 different types of trigonometric relation again. So I've got cosine squared and sine. So what I'm going to do is I'm going to jump in again with the Pythagorean trigonometric relationship, I'm going to say cosine squared theta plus sine squared theta equals 1, which implies that cosine squared theta equals 1 minus sine squared theta. So I'm going to rewrite this equation. We're going to start again from this side over here. So I've got two lots of 1 minus sine squared theta minus sine theta equals 0. So I've got 2 minus 2 sine squared theta minus sine theta equals 0. And now I have just that one type of trigonometric relationship. I just have sine theta. So I've got 2 sine, I'm just moving it all over the equation sign just to make it a bit neat. I just prefer looking at it this way. Sine theta minus 2 equals 0. Now we can solve this equation by just making a convenient substitution. So all I'm going to say is I'm going to say let sine theta equals x, and suddenly I have 2x squared plus x minus 2 equals 0. And we can solve this equation for x using our calculators or by using the quadratic formula. So just for simplicity, I'm going to put this straight into the calculator. So 2x squared plus x minus 2. So I'm going to go home, equations, add equation. I have 2x squared plus x minus 2. Minus 2, let me just check that that's right. 2x squared plus x minus 2, yep. So we go, okay, we're going to go solve. And I've got these really delightful roots here. We'll just round that to a couple of decimal places. So I'll call that minus 1.28 and 0.78. Minus 1.28 and 0.78, which means that sine theta equals minus 1.28 or sine theta equals 0.78. Now I'm only going to have solutions if when sine theta equals k, if k is between minus 1, k and 1, which means this will have no real solutions. So my only solution set will come from this one here, sine theta equals 0.78, and I'll go ahead and solve that one in the normal way. Cool, I think that's it.